Welcome to REM Reward, the podcast that explores the secrets of sleep and psychology. I'm your host, Ryan, and in each episode, we'll dive deep into the world of sleep and other topics such as mental well-being and personal growth. If you want to unlock your full potential and receive the awards that come with understanding the power of sleep, you're in the right place. To discover more tips and insights on improving your sleep and overall well-being, visit our website and explore our other episodes at remreward.org. Hey everyone, welcome to the REM Reward podcast. Today we are joined with Eitan Schechtman, who is an assistant professor of neurobiology and behavior at the University of California, Irvine. Dr. Schechtman has research interests such as sleep, memory, cognitive neuroscience, and the EEG, and has been studying sleep and memory for over 10 years. So my first question is, can you just introduce yourself and how you became interested in the area of sleep and memory?
Yeah, so my name is Eitan. I got my PhD from the Hebrew University of Jerusalem. I'm currently an assistant professor at UC Irvine, the University of California, Irvine. Before that, I worked at Northwestern University in Illinois for a few years. I ventured into this world of sleep a few years ago when I started kind of acknowledging what a big kind of black box it is. So we know a lot about our waking lives. We know what our brain is doing for some of the time, even though our understanding is not great. But then, like a third of our lives, we basically turn off and we have no idea what's going on. It's a big challenge because you can ask a waking person, what are you up to? What are you thinking about? You can look at the brain activity for that person and then compare that. But during sleep, it's a huge challenge. You don't know exactly you know that the brain is doing stuff, but you can't compare that with anything because there's no conscious sensation. And I'm up for challenges like that. I also thought that the tools that have been developed over the last few decades have reached a point where we're able to tackle that challenge and able to actually try to start and answer these big questions.
Right. Thank you. And can you just provide like a brief overview of how sleep is correlated with memory and why it's an important area of study?
Yeah, sure. So for almost 100 years now, since the first study on sleep and memory came out, we've known that sleep is related to memory. Specifically, there's a few different domains of that. The one that people most talk about most is that sleep improves memory. So you learn something before sleep, and then you're tested after, and in the middle there's sleep, then you're more likely to be correct in a variety of different sorts of tasks. It could be tasks about things that you need to remember. It could be like motor tasks, like, the kind of tasks that mimic like riding a bike or doing something really fast or texting on your phone really fast. So those kind of things, those kind of skills also improve from sleep. There's other aspects of sleep that also improve, for example, new learning. So, other aspects of memory that also improve from sleep, such as new learning. For example, if you sleep and then learn something, then you're more likely to remember that something later than if you do the exact same thing after a long period of time being awake. And that's kind of intuitive. When we're tired, we're not very good learners. But that's also an impact that sleep has. It kind of refreshes our system in a way that we're ready to encode and create new memories.
Right. Thank you. And can you talk about how quality sleep is really important and kind of includes factors like sleep duration and interruptions and how that affects like memory function?
Yeah, so sleep is divided into different stages. Going from the first stage of sleep when you just fall asleep, called stage one. It's kind of that stage when I wake you up, you might not even have been aware that you've been asleep. And going deeper and deeper up until the deepest stage of sleep, called slow wave sleep. Slow wave sleep is a stage of sleep that's called that way because if I look at your brain waves, your electrical brain waves during that time, you would see these huge fluctuations, these huge like waves going up and down about once every second or so. That stage of sleep is actually most related to memory processing, and importantly, you have to go through these stages one by one. You can't just fall asleep, and you usually don't fall asleep and go immediately into the deepest stage of sleep. So it has to go really, really gradually. It takes sometimes people in our lab several minutes or sometimes even dozens of minutes to really reach into those deepest stages of sleep. And those are the stages that are most important. So if you have some sort of condition that makes you wake up every like 5 minutes, or you're sleeping in a noisy place or something and keep getting up, or I don't know, you're sleeping in a bus and you keep getting woken up time and time again, you're probably not going to reach those stages of sleep as much as you should, and as much as you usually will get to during your sleep. I don't want to mention that there's one more stage of sleep that I didn't mention. That's REM sleep, rapid eye movement sleep, as I'm guessing your listeners know, because that's the name of the podcast. And that one is associated with those vivid dreams. So this one is kind of on a different scale. It's not necessarily less or more deep in many ways. It's just very different. It's just a different sort of animal than all the other stages that kind of go gradually deeper and deeper into sleep. And that one also contributes to memory in ways that we don't understand as well right now. But specifically, when you talk about quality sleep, usually what you mean is uninterrupted sleep, or sleep without arousals. That's at least one definition of it. Quality sleep is like, there's different ways you can think about it. And in general, the more stable your sleep is, the less interruptions there are, the less arousals there are, the deeper you go and the more you stay in those deeper stages of sleep, which are really important for memory, not only for memory, by the way, for just about any function of sleep that we're aware of.
Right. Thank you. And you may have really briefly spoke about this before, but can you just share some key findings from your lab's research on sleep and anything related to that?
Yeah, sure. So our lab here at UC Irvine studies sleep in mostly healthy participants. So there's a lot of labs that do like studies on older adults that might or might not have dementia, or people with sleep disorders of various types. So we mostly focus on the healthy student population here at Irvine. And what we do is we look at their brain activity while they sleep, and we try to see what we can learn about what their brain is doing during sleep. So a relatively easy experiment you could do is have participants learn something and then either sleep or not sleep, and then test them after that. And we do that sometimes, and people have done that in the past, but it still leaves the open question of what is the brain doing during that time? What is it that the brain is doing while a person is asleep? And that's a hard question to answer. Again, for the reasons I mentioned in the beginning, you can't ask a person, what were you thinking about? They weren't thinking of anything. They were not conscious while during that time. But if we use different techniques, such as EEG, so EEG is this set of electrodes that we place on a person's head, and we can read the electrical activity from their scalp, which is actually reflecting the activity in their brains. So you can actually read the brain activity from a person's scalp while they're awake, while they're asleep. Those slow waves that I mentioned earlier, that's something that we see in EEG. We see those in these electrodes that we place on people's heads. So you can, using that information, using that activity from people's heads, you can actually start to study what the brain is doing. You can, it's kind of a peripheral signal. It's not very strong. It doesn't tell you what individual brain cells are doing in any way. There's billions of brain cells, dozens of billions of brain cells. That doesn't give you information about that a lot. It doesn't give you information about what the brain is doing in general. And we're using these kind of techniques to try to read out the information that is being processed by the brain while a person is asleep. So we use EEG. We also use functional MRI. MRI is this big, huge magnet that occupies the whole room that people can go into, lie in there, sometimes sleep in there, and you can look at the changes in the blood oxygen levels across different over time, and that helps you understand exactly which areas of the brain are active. So that's what MRI does, and it has some benefits over EEG as well. So sometimes we use those. The last thing I want to mention that the lab does is so up until now I told you how we record from the brain. We look at the brain and we see what the brain is doing, and it's the one providing the information to us, and we're here to observe and learn. But a good practice in science is not only to observe, but also to control certain things. And what we do in the lab is we actually have a technique that we can control which memories the brain is processing at a given time. So we don't just look at the brain and see what it's doing and then just kind of observe and understand, but we actually bias the brain or shift it towards a certain mode of processing, and then later see what the impact of on memory would be. And that's called the technique is called targeted memory reactivation. And the idea there is that we basically present stimuli. So stimuli means like sounds or images, or well, we don't present images during sleep, but sounds or odors or smells. We present those during sleep, and specifically sounds that are related to something that was learned just before sleep. And we observe how those actually get selectively better after we do this manipulation. So we can actually control what your brain is doing during sleep and record to see the patterns of memory reactivation. And together that gives us a pretty nice, neat story about how sleep helps memory. Yeah.
Perfect. That's super interesting. Thank you. And what advice do you have for like young adults or students to optimize their sleep for better memory retention or learning?
Yeah, so that's a great question. I think that's come up from just about any study that you can with adults or with kids or with anyone is routines. So our bodies are wired in certain routines. You get hungry at lunch, right? You
Right.
get tired in the evening. Just about anything in your life follows some routine. Usually it's those 24-hour routines that are guided by external sunlight and light in general. And sleep is no different than that. I remember when I was a kid and I wasn't very aware of sleep and sleep's contribution, I would basically, sleep deprive myself. I would, go to sleep really late, wake up pretty early. I don't know if some of your listeners might, not have a chance to sleep in even a bit because their school starts early. That's a huge ongoing debate in sleep-related debate in this country about what school times should high schoolers should have. And in some states like California, where I am, it's actually by law it has to start no earlier than 8:30. So I would have like these weird irregular sleep patterns, and then come the weekend. In the weekend, I would sleep in until 1 p.m. That's what I would do, and I definitely recommend against that for several reasons. First of all, your body is not really wired to do that. Think about ancient times. In ancient times, there wasn't school, there wasn't even electricity. You went to sleep when the sun set, and you woke up around the sunrise or so. And every day would be basically the same. Okay, over seasons it might change a bit from here to there, but you had a regular routine. That's how our bodies are wired to work. They're not wired to sleep deprive ourselves and then compensate for that. You can't really compensate for that. The fact is that over time you're losing sleep. It's not like if you sleep over the weekend, you're gaining everything that you lost along the way. You're not in terms of memory gain, but not in terms of other aspects of health too. So sleep is related to a bunch of different, so mental health, it's related to physical health, it's related to cognitive, healthy cognitive aging. All these things are really linked with sleep, and all of them depend on sleep following this routine. So I would recommend, sleep in a bit, sleep in an hour more than what you would. But in general, try to keep your routine as much as you can. Your body will thank you, and your memory too. And maybe the last thing I want to mention in that respect is that there's a study that came out last month, I think, maybe the month before, that looked at first-year college students in, I think, 5 different institutions. So really relevant to people who are listening who might be freshmen next year or the year after that. And what they found was that people who slept more, people who prioritized their sleep, got a boost in their GPA months later. So they looked at the sleep in the first semester. They looked at the test results at the end of the year, and they saw that people who made sure to sleep well got a boost in their GPA, and that was across 5 different institutions across the United States. And if that's not a good enough reason to prioritize, so I mentioned routine, but I didn't mention how much to sleep. So importantly, give yourself time to sleep. different people differ in terms of how much they need sleep. So how much sleep they need. Everybody needs sleep, but how much sleep they need. It's
Right.
not as if 8 hours is this magical number. And in general, people around adolescence need closer to 9 or 10 hours a night. But it differs between people, it differs across life. Some people, sometimes you'll need more, sometimes you'll need less. That's fine. The best way to know when you have slept enough is when you wake up. When you basically
Right.
your body has its own mechanism of waking up when you have enough sleep. So and we know that people differ in terms of how much they sleep, but make sure to sleep the amount your body needs, wherever that may be, and it's probably not going to be less than 6 or 7 hours, and in adolescence probably no less than 7 hours or so.
Yeah. And my next question is, so I know you talked about how sleep is so important. I think that's the big topic here, but what are some potential long-term consequences of not getting enough sleep or like irregular sleep patterns or sleep deprivation?
Yeah, so the I think that in a lot of ways we don't really know a lot about the long term. A lot of the studies that have been run are studies that are either at the moment, like tell you
Right, right.
what's going on right now, or studies that look back at history and ask you a year ago how much did you sleep. But that's really hard to make. First of all, you don't necessarily remember all those details, and also those are correlations again. Those are like these
Right.
links, but that doesn't mean necessarily that sleep is what caused you to be what you are today. The short term implications are far better understood, and they concern just sleep, mental health, and physical health and aging, as I mentioned before. Those are the major aspects that have been studied. Some of these, the ones especially for in terms of like of dementia or for older adults, there's been studies that are a bit more longitudinal, so looking over multiple years and looking at how sleep at one point relates to cognitive decline later on, and there's definitely links there. Even though it seems to be some circle, so it seems that sleep impacts Alzheimer's disease, for example, and Alzheimer's disease impacts sleep and so on.
Right,
So
right.
that's all older adults. For kids, there haven't been a lot of studies that have looked over a long period of time. There's been a lot of studies in kids and adults and a lot of college students, so younger adults that have looked at more of the night by night kind of
Right.
the impacts of sleep on all these different aspects, and just about any study that looks at that does find that there are indeed clear benefits to sleep, and then very, very clear detriments to sleep deprivation of any sort. One thing that I haven't mentioned that is really relevant, I think, for this age group is driving. So what a lot of studies have shown that when you are driving sleep deprived, it's about as so sometimes it's worse in terms of your driving ability relative to being drunk. So sometimes if
Right.
you're even sleep deprived, like if you sleep, I think that study was like 4.5 or 5 hours a night for a few nights. Basically, you're driving worse than you would with a large percentage of alcohol in your bloodstream. So so definitely sleep deprivation has impacts outside of the world of memory as well. And driving, I think, is a good example of that.
Yeah, I agree. And as an expert, what recommendations do you have for students who often face sleep challenges, but they're due to academic demands?
Right. So I think that a lot of it is prioritizing, is a matter of prioritization, because yeah, they do guide. I mean, there are guidances as to when you have to wake up, but there aren't very strict guidances as to when you have to go to sleep. Now, I know that adolescents in general, this is a scientific fact that adolescents have a circadian shift, so that they feel tired later than children did or older or adults do. So it's not just you. I mean, you are
Right.
tired later. But once you are tired, that's the time to go to sleep. And and it's becoming more and more challenging, especially because a lot of the social interactions happen during later at night, like 11, 12 p.m.,
Right.
sometimes even later. There's you might be texting someone, and then that's the time in the day that you're feeling that you have the time to really go into it, and and have those conversations. So you can't, even if you can't decide when you fall asleep, when you wake up, you can usually have some control over when you fall asleep. And again, routine is super important here. If you establish a routine, it might take you some time to really establish it, but once you establish it, then you'll find that it works, and your body is used to it in a lot of ways. I wouldn't recommend going to bed when you're not tired. So that's not what I'm saying at all. I want to stress that out, because I want to stress that, because that stresses people out. When they lie in bed and aren't able to fall asleep for an hour or two, that's unhealthy. So go to sleep when you're tired, not before, and definitely not after. And try to keep a routine as much as you can, because once you get into that routine, your body will really help you keep that schedule as long as you're willing
Right.
to follow its lead.
And just like off that, I just wanted to bring up, like, can technology or the use of devices kind of change your feeling of when you're tired, or can that like kind of set it back?
So there's a lot of research on the effect of light on sleep. So going back to those ancient times, which I mentioned before, back then, you might have a fire outside your house and so on, but basically people followed the sunrise and set for most purposes. And now we have these bright white lights that are out there, and our phones also project very, very strong lights. I think probably everyone knows already that there's filters you can use to reduce the amount of blue light that is the one that really drives your circadian rhythm. So what is circadian rhythm? Your body is basically using the light outside to create its own 24-hour rhythm. So it's using the light from outside as kind of a guide, as kind of a teacher to create your own 24-hour cycle. That's why if we go to another state or another country that's in a different time zone, it takes us some time to kind of adjust, because our body is used to a certain clock that we had from before. The way this teacher works is through different things like exercise and eating and stuff, but mostly through light. Light is like by far the biggest one of them all. If you expose yourself to really bright light during late at night, then you're basically telling your body it's daytime. It's not time to sleep. Try to avoid that. Try to create transitions that will mimic how the sunset would have worked in back in the day. If you can avoid bright lights during the hour before you want to go to bed, that's great. If not, at least use filters. Right now, you can actually buy like light bulbs that don't have the wavelengths that correspond to the blue light. There's different things you can buy, or different filters you could use that really help with that. I don't think anybody would do that, but you can put sunglasses on in the middle of the night, in the evening before you go to sleep. But just prepare your body gradually to sleep. Our bodies are used to gradual transitions, just like the sunset and the sunrise. They're not used to being in sunset all the time, and then suddenly you close eliminate the sun immediately. That's not how it works. So make yourself, have a bedtime routine. Bedtime routine is not something that is only true for 5-year-olds. It's true for all of us. Have a routine around the same time, which gradually kind of reduces the amount of light that you are exposed to, and that's true for your electronics and for lights in your room or wherever you hang out.
Yeah.
Well.
Yeah, it definitely shows how important routines are. And just for my last question,
maybe one last thing about that.
Yeah, go for it.
So you mentioned electronics generally. So I would say that try to avoid like very engaging, anxiety-provoking, like super high stress stuff from your I don't know, TikTok feed or whatever, just before you sleep. Again, create that gradual decline. None of us can turn off like a light switch. None of us can go from 100% to 0% on command. We all need these gradual transitions. And part of that is also not getting worked out over something, because that would make it even harder to fall asleep.
Right. Thank you. And just for my last question, I just wanted to ask, so for everyone listening, what is a key takeaway or a few key takeaways you would like everyone listening to remember when it comes to utilizing the power of sleep for memory or learning or just in general?
I would say prioritize sleep, just like a lot of you, I'm sure, exercise. So you prioritize your exercise, you find time for it, you make sure that it's that it's not something that it's something that you find time for in your day. Prioritize social engagements. So think of sleep not as something that you have to do, and this time, this wasted time, like some people might think of it. Think of it as something that you need to prioritize for your own health. You need to set up a routine for that. You need to give it its time and space, and give it yourself an ample opportunity to reap most of the benefits from it.
Right. Thank you. I think those are all my questions I have. Thank you so much, Dr. Schechtman. It was really, I really appreciate you taking your time to join and share your insights. It was a pleasure. Thank you. Thanks for tuning into the Reward Podcast. Before you go, we'd appreciate your support by subscribing, liking, and leaving your thoughts in the comments. Stay tuned for our next podcast, where we'll be joined by a special guest speaker to explore even more about the fascinating world of sleep and psychology.